Okay, so this is going to be the last video for the arithmetic and geometric sequences. I might do a review video at the end just to kind of go over everything one more time, so you can watch it before you take the quiz or whatever. But this is going to be the last one that actually covers new content. So let me make sure. Okay, cool. We're in the right color. So we're going to start by talking about how to write formulas of both arithmetic and geometric sequences. This one goes along with IXLP7. The next one goes along with IXLP8. So writing the formulas of arithmetic sequences, we need to write them. Remember, the form is T sub n equals T1 plus n minus 1 times d. So this is kind of a generalized form for all of these, but this can cause a little bit of a problem in terms of actually solving for the equation, because we're not going to keep it in this n minus 1 form. We're going to end up writing it like this. So Tn equals T, and I'm going to call this T sub 0 plus nd. And the reason for this, you'll see in just a little bit. And actually, maybe even switch the d in the end. Doesn't really matter. But to write the formula of the arithmetic sequence, the first thing you need to do is identify the rate of change. The rate of change is going to be written in front of n, and then you're going to plug in 1 for n to figure out what you need to add to create the first term in the sequence. Now, that seems like a lot of different stuff. I would strongly recommend writing these down, so give like just a second. You're probably going to want to pause the video to make sure you have time. But basically, I'm going to go through some examples of how this actually works. So we're going to start by writing the formulas for the following sequences. So we have -5, -3, -1, 1, 3, 5. So obviously each time this is going up by 2. Adding 2 each time. So my rate of change is 2. So I'm going to put 2 n right here. Then what I need to do is plug in 1 for n to find T1. And it's going to be plus, I'll put a question mark for now. So Tn, or 2n plus question mark equals T sub 1. So my T1 is -5. So -5 needs to equal 2 times 1 plus question mark. That means -5 equals 2 plus question mark. So we need to figure out what plus 2 equals -5. The easiest way to do that is subtract 2 from both sides. That gives us -7 equals the question mark. So my formula should be, when I finish writing all of this out, let me erase. (2n plus -7). Now, once I have a formula, I can be done, but I can also go back and actually check it against some of the terms. So let's look at this. This is the fourth term, number 1. So my fourth term is 1. So if I plug in 4 for n, I should be able to get 1. So I have 2 times 4 plus -7. 2 times 4 is 8. 8 plus -7 is in fact 1, which is what I'm supposed to have. So this formula checks out. So right there, 2n plus -7. I'll rewrite that in just a second. 2n plus. We can also write this as 2n minus 7. Either one of those works. Now the next one, we've got a pretty easy rate of change here. So 95 to 96, we're going up 1, up 1, up 1. So my rate of change is 1. So I'm going to have 1. And then I need to figure out what I'm adding so that I can get 95. So again, we'll plug in 1 for n. So 1 times 1 plus something equals 95. This is 1 plus something equals 95. Subtract 1 from both sides. And then question mark must be 94. So 1n plus 94 is going to be the formula for this one. Let me do some erasing really quick. And keep in mind when we're writing variables with a 1 in the front, so 1n for example, we don't actually need to write out the 1, so we can just write n plus 94. And that's going to be the formula for this one. The last one, I'm going from 7 to 14, 14 to 21. That's plus 7 every time. So my rate of change is going to be 7. So 7n. And then I need to plug in 1, figure out what I need to add to get the first term. So if I plug in 1, I'm going to have 7 times 1 plus question mark. Whoops, I don't know why I put that line there. Question mark in parentheses, I guess. Plus question mark. So 7 times 1 is 7 plus question mark. And it needs to equal 7 because it's the first term of the sequence. So obviously this is going to have to be 0. So when the question mark is 0, all we have to do is just write the number in front of n. So 7n is going to be the formula for the last one. So this might take a little bit of practice. This is probably one of the more difficult parts of this whole unit. But hopefully it's not too terrible. Again, your first step is to identify the rate of change, write it in front of the letter n, and then figure out what you need to add in order to make the first term when n equals 1. Now, geometric sequences are actually easier, despite the fact that they're much larger numbers and they go up much faster. All we need in a geometric sequence is the first term of the sequence and the multiplier. We're going to write the first term first, then in parentheses, we're going to take the multiplier and raise it to the power of n minus 1. And we're literally going to write n minus 1 when we do this formula. So, for example, this one, we start with a 3. Our multiplier, we multiply this by -2. We multiply this by -2. And we multiply this by -2. So my multiplier here is -2. And it's going to be to the n minus 1. Just like that. That's all we need to do. So this one, we've got 4 is the first term. The multiplier is 4. So each time we're multiplying by 4. So we're going to have 4 times 4 to the n minus 1. Now, interestingly, this is a very rare specific type of example. When the multiplier and the first term are the same, you can actually just write the number to the n. This will work the exact same, but for the sake of doing your IXLs and stuff, and for keeping it similar, this is probably a safer way to do it. So technically, this works as well, but I would recommend starting with this one. Now here, this is a little bit interesting. We're multiplying by 1/2 every time. So again, you have to make sure that you're using multipliers here. You can't do it divided by, so you can't say it's divided by 2 instead. It has to be times a fraction in this case when it's getting smaller. So our first term is 16, and then we've got our multiplier, which is 1/2 to the n minus 1. Now I'm going to put this in parentheses actually. I'm going to do a double parentheses here just because I want to make sure that we understand it's the whole part of this 1/2, so it's the whole fraction being raised to the power of n minus 1. Oh, this is minus. Oof, okay, that got a little rough. Let me erase it, rewrite the whole thing. Oh, or erase everything and rewrite all of them. That's fun. Okay, so here again we had 3 times -2 to the n minus 1. Here we had 4 times 4 to the n minus 1. And here we have 16 times 1/2 to the n minus 1. And those are all of our geometric sequences here. And I believe, yep, that is it for what we're doing for this unit. So with the information on this one, you should be able to do IXLs P7 and P8. Again, this is probably, I think, the trickiest part in my opinion. Just these last 2 little bits. So if you do have trouble with this, Friday school lunches or just anytime we have extra time during classwork are a good time to ask for help with these. Once you finish the last of the IXLs, take a look at the study guide. I'm not going to require the study guide to be done before you take your test. However, I would strongly recommend looking at it because it will tell you exactly what types of problems you need to be able to solve. If you really want, I can print you a copy of it as well. Just give me some warning on that. It'll probably have to be the next day before I can actually get it to you. So, let me know if you do want those. And then the test, like I said, once you finished all the assignments, you can show me that you got them all done. Let me know. I'll get you a copy of the test and we'll figure out a time for you to be able to take it. You will get your notes on the test. I'm not sure about a calculator because I'm recording all of these videos on the same day. But I will figure that out and let you all know. Hopefully that's it for this unit. I don't think there's anything too terribly important anyway that we're missing. If you have any questions or anything, please just let me know. You can send me an email anytime or ask me questions during class and I will do my best to help you out with it depending on what we're doing. But yeah, that should be it.